Hi, it's Ray from Pro Shaper Sheet Metal, and now we're on 8B of building the all-aluminum E-type nose bonnet. This was the last piece that we did last week. It's kind of unimpressive right now. Didn't get too many views, maybe because it's not that impressive, but I put some other content in I thought was pretty impressive. But now we're going to set the arrangement on this. We've got the area value correct. Mark punched all the holes out on the flexible shape pattern. We've transferred them all to the piece of aluminum. Pull this off. I need a paper towel, 1 second. The flexible shape pattern is still giving off a little bit of plaster dust. There's all our marks. I didn't put the gauge numbers in. I got to do that yet. So take the black pen, and we have gauge number 31. On the gauge numbers, I like to put an underscore and an arrow where they're appropriate. And this is gauge number 35, gauge number 40, 41, the center one is 30B. This one's 42. And the last one is 43. Now, this is something that's really important. When you're making a panel like this, I probably mentioned it before, but I'll mention it again. You always want to leave extra material on the sides. I don't have a whole lot here. I don't really need too much, but I only got 1/4 of an inch or so. Here I've got a bunch. That's the front of the panel where it's going to join up with the frontmost part of that power bulge. This is the back edge. This back edge on E-type is a raw edge. They don't hem it over or anything. It just stays as a raw edge. We could put a hem on it. It might be better, but that might cause a fitment problem too. So one thing I didn't do is I cut this with the shear and it leaves a little rolled edge here, so I'm going to run that in the wheel first. But the flexible shape pattern was fitting really good. The edge is rolled a little bit from the shearing operation. You can fix that by sanding it with 80 paper, or I'll put it in the wheel and I'll just roll the edge back on the wheel. It'll take 2 seconds. So looks like I got to change out the anvil on the English wheel. But I was mentioning these extra margins, we will not cut these to size until we start doing the welding. Now, the first welding we're going to do is we're going to be welding this panel to the one that was in front of it. The one in front noses down, like this, I call it the power bulge. So that one has extra on it. We're going to determine, the line is right here, and that's determined by the flexible shape pattern, and there is a witness line right here. That's where the welding has to go together. So the other panel will have a witness line, this one will have a witness line. So that's another feature of the flexible shape patterns, is you line those witness lines up and you make sure that everything is welded properly. So we'll redo this line. I've got it done in a regular magic marker, and we're going to do it in a superfine marker. Unfortunately, I still have to revert to the Sharpies. Milwaukee's have not made a superfine as far as I know. And these things are really temperamental. You can get them brand new and sometimes they won't work. To reactivate it, you can just put it on a piece of paper and then it generally works. You can't push too hard on these. The felt end gets really bugged up quick. So I want to roll this edge. I got to change the anvil out. We'll do that. And then we've got all the arrangement lines here This is a pretty good radius, good size radius here, where it's going to meet up with that frontmost section, and then it tapers all the way to almost like a 70-degree or 50-degree angle or something like that right here. We have a gauge for that, but it's a real tight radius right here, and this radius actually makes a little bit of a turn right here. Now generally when you make a radius in sheet metal, it will immediately go dead straight. You put a straight edge on it and it'll go dead straight. But this one has a little bit of curve to it, and I'll put a straight edge on it showing you that. And when you have a curve, you have to have extra area present. So this has been wheeled over in here, and it's a little fat in here, allowing it to make that curve. So I got to change the anvil out. I'm going to clean these edges up, and then we're going to start setting the arrangement. Okay, I've cleaned up that edge just by rolling it in the wheel. I changed it out to my workhorse wheel. I use this like all the time pretty much. And I do need a little reverse curve, a little edge stretch on both of these flanges over here. These are going to become flanges. Now, if I put too much stretch on that edge, and I do that just by wheeling right on the edge like that. If I put a little bit too much, it's very easy just to bring it back with a kick shrinker. So I can't do it all on the edge. I got to bring it in a little bit. That flange is about 1.25 inches wide or so. So I'm going to put a little bit, and I'll use the flexible shape pattern to gauge what I need. But if I need to go up or down, more edge stretch or less edge stretch after, I can do it with the kick shrinker. So I'm just going to get a little bit started here now. That should be good enough there. We'll check it against the flexible shape pattern. See, now this edge is what I call a tight edge. See, it's not doing anything. And now because I've stretched this edge, see how it's springy? That's what I call a loose edge. All right. And I think I've probably mentioned it before. When you're building panels, shaping them to start out with, this is a very, very common thing you're going to see on just about every panel is a loose edge condition like this. In this case here, we want the loose edge. But in a lot of cases, you don't want the loose edge. If you, this has got a little bit of reverse here, but if there's no reverse present, you don't want the loose edge. So to fix that, a lot of people will go over to the shrinker when they're building a standard compound curved panel, and they'll shrink that edge, and it makes all the little shrinker bite marks on there. Even if you have stipple, it makes a little mark. I much prefer to do the 45s, which I've mentioned, I'm sure, a few times in my other earlier videos, but you got to get into that habit. When you see this edge loose like that, you just 45 it. That equalizes it, and it'll tighten that edge up in a matter of minutes. So once you understand that, it's like a magic trick that you can use. So we'll do a little bit on this edge too. Okay, now that edge is, now a little bit more. Get it even with the other one. See, and I'm working in the center of the lower anvil so that I get good action on there. Okay, let me see what we got. Now, we still got more here on this side, so a little bit more. All right, now it's starting to come alive there. So now we'll check it with the flexible shape pattern. I had a comment in the comments section from one of the viewers saying that the flexible shape pattern absolutely cannot work. It just doesn't work. And I I kind of disagree with him a little bit, because we're going to see an E-type all aluminum nose built with just using the flexible shape pattern. So I always say the proof is in the pudding. So, and also I responded to him and I said, I don't know how a magnet works, but a magnet does work. So I know how this works. It gives you the area value. Now it looks like I need a little bit more. Why? Because when you pull this tight, there's still a little, I call this pinch and an inch. I might have mentioned that before too. If you got a little extra material here. So this side here, I could stand to give it a little bit more too. So I'm going to give it a little more on both sides, and then we're going to start setting the arrangement. It's a dull panel right now. Doesn't look like anything. It comes alive generally when you start setting the arrangement. The arrangement value is what everybody identifies with, because that does the bending that makes the panel look like what it's supposed to look like. The area value just simply adds the area that's required, and it's oftentimes confusing, especially if you haven't done that before. Take the perspective of building a panel by defining the area value exclusively first. It took me a while to get my head wrapped around it. So, still looks like I got more on this side here. Let's check it with the flexible shape pattern again. I got front and front. Always make sure you're oriented properly. I usually will tape this down, but it looks like I'm good there. Looks like I'm good there too. So we might be ready to go. If we don't have enough area in here, is it a disaster? No. If we have too much area value in here, which I doubt, we did that a little bit on the front piece, is that a disaster? No. Everything that you do, whether you're fitting to a buck, wood buck or wire form buck or whatever method you're using, you're not going to be absolutely perfect on everything. So you're going to have to learn to correct after. There's always going to be a spot that, you know, well, I wish I had done a little bit better there. It's a little bit low. Well, those can be brought up later with planish and hammer, a dolly and a slapper. You can do it like the Italians did. If you have an underdeveloped area, you can put it on a nice surface ground plate and just hit it with a hammer a little bit, and that will add a little area right there, right in the exact spot that you want it. So this is the fulcrum block here, and we got a little leather on this, and it might be a little sharper than I want for this end, so I'm going to put a blanket on it. I find these Harbor Freight blankets work really well. They're inexpensive, they do the job. They kind of break up pretty easy, but they're cheap enough. So I'll put some gloves on and see if we can set this arrangement. So, well, first I'm going to need the correct gauge. So I need gauge 31, 35, and 40. All right, so this is that 37 Riley we showed a little bit before, an 8A, I believe. And the fenders on it, this front fender has really been beat up. It's been worked to death. I think there's a bracket right here, and typically where fenders have a bracket like that, they seem to get a lot of flexing, and they'll always break right in here. And the bead has been just beat up to death, and the only way you could fix that would be if you'd leaded the whole thing. So there's a lot of weak spots. There's been a really bodge repair of putting in a new piece right here where it must have cracked on top, and it's just been hammered to death every which way. It's bulged over in the corner over here. Even though it's bulged, it still has the fundamental essence of the area and arrangement value, and you have to overlook some of the mistakes that are in it. So Brian from Ohio is working on this, and this car belongs to a guy from Tennessee, Mike, and it's been banging around since 1974, and he really wants to get it done, and he really wanted to smooth all this stuff out. And there's a bunch of patches that have been put in the fenders improperly, and they've just been abused through the years so bad from bulge repairs. It's just a lot easier to make new. So the reason I'm showing this is, can you imagine how long it would take to make a wood buck or a wire form buck of this? It'd be a considerable amount of time, and a lot of people approach it, well, they got to scan it and then they correct it in the software, and that entails having all those different skill sets. And the average person working in his two-car garage is not going to have access to all that. Yes, that can yield a really nice result, but simple tape with my flexible shape pattern, which Brian had very little knowledge of before he came here, and he's done smaller panels but nothing on this scale here. And what we did was we looked at the Fender, how it was built, the original pieces in England, and they made it with what this is called a cheek piece here, I believe, and then that's one piece. Then they have a little center section here, and then they got an inboard piece here, and then there was a weld around here or so. And this panel has a lot of area value change in it. This panel is all arrangement. It's basically a flat panel. Brian's got that one made, and you have to make all the gauges, the flexible shape pattern and everything. He's got that all set, and he made the flexible shape patterns for this one, and here's the result. So the people that don't believe in flexible shape patterns working, there's the result right there. And he's still got a little bit to do, a little dressing here and there, but it's so much easier to dress this clean metal. This edge gets wired, so the bead distance and stuff will be changed a little bit when we put the wired edge in there. But he's not going to do that until we weld this section on. So he did a really nice job on it. It's nice and smooth. There's a few little spots that got to be picked up. Brian was an excellent welder. I showed him a few more tricks, and we get basically an invisible weld when you're done. This was done with a TIG. I prefer the TIG. This is 19 gauge steel. It measures about 40,000 stick or so, and it gives you really good dent resistance. So I just wanted to show this as a confirmation of how good a job you can do with just using a flexible shape pattern. And they're very easy to make. Flexible shape patterns and the gauges. The gauges we make out of cardboard. Yeah, and this is the rear fender that London made. Brian helped him a little bit with the welding. It still needs to be welded in the center. It still needs a little dressing on the bead and stuff. And that will be completed. And that was all done with flexible shape patterns too, as well as the new Bootlid, which I was featured in the 8A segment of the aluminum nose. Now, a lot of people made comment of this Renault Le Car in the back, and they thought it was an R5 Turbo. It's actually not an R5 Turbo. It's another extended learning students project. He took my class, and then when you can buy a certain amount of time. London bought I think the 130-hour special, and it took it all in one go. And Brian's here for a month, and also Esteban is doing the Le Car, and he's here for a month, and he's going to be buying multiple months probably, because that's a long involved job. And his intent on it, well, what it is a Le Car that was converted into electric in Massachusetts back in 1981. I believe it's an 80 or 81 car, and it only has like 20,000 miles on it, but it rusted up. And he wants to First he was going to turn it into an R5. He found the original sheet metal to turn it into an R5, which has a mid-engine instead of a front engine. And then he changed his plan to, now he wants to do Tesla power in it. So he's got a Tesla drivetrain that he's got lined up to purchase, and it's going to have a tube frame inside it. Basically going to have to gut it out inside, and it'll go from, I don't know, 58 or 68 horsepower to 250 horsepower. So it should be a screamer. And he's addressing a lot of the rust. The unibody in the front, the chassis pieces have a lot of rust in them, and I really counseled them to do a fresh build on it. If you want the ultimate Renault R5 but be a electric instead of a piston engine, make a tube frame out here using that as a measuring tool. That's what I do with all my student build projects. Install your Tesla drivetrain in the back, which is a self-contained unit, into your tube frame. Put a aftermarket suspension on the front and right wheelbase and everything, and then build a super Ligera inner structure, and then make all aluminum panels. The lacquer panels are actually pretty easy to make. And then you'd have an aluminum body with a integral roll cage and 250 horsepower. It should be a fun little car. But I'm still working on Esteban on that. He still wants to fix the rust. I absolutely abhor rust. It's just such a nuisance to work with rust. It's so much nicer to work with new metal, and that's what I try to stress. New metal, new projects, that's where the hobby has to go, in my opinion. So let's go back to that aluminum E-type nose. Alright, so here we go. We're going to try to set this arrangement here. I've got my gauge number 31, 35, and 40 right there. And this is the wider radius. So this will be pretty stiff right here. We might have to employ the use of a slapper to get a little persuasion going here. Now you can't expect to do this all in one go, so you got to do a little bit, a little bit, a little bit, a little bit, and it finally yields. And if you try to get too much at once, it'll kink on you. Now we might revert to the wheel, because the wheel can pull this down pretty easy, but we'll try here first, or at least get it started, and then maybe go to the wheel. Plus we have the slapper. So I got this fulcrum block set kind of low for me, because what you want to be in a position where you can put your weight into it. If you're up high like this, then you have to use your muscles, and you don't want to be there. You want to be able to throw your body weight into it. So again, it's a little bit, a little bit, a little bit. And I'm guiding myself by these blue dot lines. That's the radius zone right there. Now we'll go back over this side. I'll probably bring it into the wheel and see if that will pull it down a lot easier, I think. And it's going to get difficult back here. I'm going to have to go to a very narrow fulcrum block to get it back there. In fact, I can probably take one layer off here, and then it'll work better for me. Go back to the other side. And you can't rush this stuff. You have to have patience. If you don't have patience, you're not really suited for this craft. You'll have to take up something else. There's a lot of perception that you can make this stuff really fast if you use some other secret method or secret tool or something. Yeah, you can if you have a big 500-ton press and you have a matched set of dies. It takes, you know, like a nanosecond to make this panel. But if you're making them by hand and you're doing them very accurately, it does take time. I think a lot of my students are kind of shocked by sometimes how much time it takes to do a panel. So we're going to try putting it in the wheel and see if we can pull it down a little bit. When you do this, you make sure that you back the pressure off considerably. Oh, I'm going to have to adjust that. That's a really nice little feature I have on this wheel. I actually found that in the scrapyard that I used to go to all the time. I think it's part of a medical equipment or something. I just incorporated it into the design instead of making it all. It's pretty inexpensive. Now, when you're doing this, you want to make sure that you don't pull too hard, because if you do, you're pulling down, but if you do too much at one spot, you'll get what I call a fulcrum mark, make a little bite mark there. You might get a few of them, even light pressure, so you got to be real careful. If you do get them, it's not the end of the world. Everything's fixable. It's just a detour to make corrections. Now later on, this flange has got to be tipped back the other way. We'll use the tipping wheel with that wood wheel that I think I used before that has the duct tape on it. That's a nice soft radius, and it'll work really nice. And then once this radius starts to go over, it really wants to go over. It's like you break its back. We got that one going good. Now we do this one. Okay, now I want to define this back section here, because I can't really do it in the wheel, and I can't do it by pushing over here. So I have to change out my fulcrum block because I need a really sharp one. So there's my locking post dolly holders. This is a standard 1-inch shaft. And make these up out of little scrap bits. I got a universal holder for it, and you can make all different ones. Now this I'll probably have to use a wood leather face slapper to get it to do what I want to. So I'll put this blanket on there. That should be good. And these are a handy little tool. You can make these up if you have a bandsaw. Bandsaw it out. Just make sure that you have enough knuckle clearance. This could stand a little bit more knuckle clearance, so a little bit of S-bend right here. And then if you're in the US, you can get this nice, I think it's vegetative tanned leather from McMaster.com. I probably mentioned them before, but that's the source of a lot of good stuff that you need. So this is going to be a little tricky here. So I got to make sure I have that fulcrum block in the right spot here. I might be better served actually by rolling this in, but then I'm going to have to transfer the marks inside. Well, let me try it this way anyway to see what happens. As I said, everything's correctable, but that correctable is a detour. The fewer the detours you take, the better. So this is number 45 here on the edge. And I don't have the 45. Let me go get the 45 so we can see how far we got to bring that down. My error, I wrote 45 here, and we're looking all over for the 45 gauge. There was no 45 gauge. It's 43. So let's make the correction. And here's what the end of that's supposed to look like. That's requires a lot of arrangement potential there, more so than over here. So I want to get this addressed because of that. So there's the bend that we want. That's the angle. Maybe it's about 45 degrees, I guess. I thought it was a little bit more. And these are the dots right here from the flexible shape pattern. So to make them a little more visible, I'm going to put them in solid like that. It merges into a radius here. This is the center of the radius here, and that's the edge of the radius. Do the same thing over here. Now, we're going to have to work from the inside of the panel, so I took and I just went like this. You can take something like this, just to transfer quickly these points. Just eyeball it a little bit here. The verification is up on the top, so I just work it a little bit, then observe it from the top. Okay. So I got some marks in there. I have some marks in there. I got to stop doing that. My third grade teacher, I think, tried to break me of that, but it hasn't happened yet. I did have a milestone the other day. I went to my 50-year high school class reunion. That was a fun time. Haven't seen most of the people since 1969, when I graduated from Shrewsbury High School in Shrewsbury, Mass. It was good. So we got that marked. Now we're going to bring it over to the tipping wheel over here. Now this is a rolling fulcrum block essentially, and I use this material here as the lever, and this is the fulcrum. So I pop that up, and that'll give me a much sharper bend, and then I verify, because there is my original marks and it's looking pretty good. I'm over here, I should be over here a little bit, so I got to make the adjustment, so I got to go more inboard. I got to get the correct angle now. So I refer to my number 43 gauge, and I put that on there, and the angle's coming pretty good. But now see, I've got this part going this way, and it actually wants to go the reverse now. That has a little rounded scallop. Well, it's the radius here that becomes a big radius when it gets over to here. So it's just very interesting to see how they design these panels. They originally were maybe a clay model or something, and that's the way the designer Malcolm Sayre saw that it worked the best, in his opinion, and it's a beautiful design. So we're trying to faithfully copy all these little details as proper as possible. That's looking pretty good right there now, so I'd say that one's done. We're going to have to tip this way now, and that will probably lose a little bit of the angle here, but we'll get back to it. Like I said, we're gonna do this in tiptoes. Such a simple tool, and it does such a wonderful job. It's just a rolling wheel. I've got a fancy, one of my old fancy English wheels being used as a frame, but you can make a pretty basic tube frame for this and it would do the job. Very inexpensive to make, and no special wheels. This is a piece of maple turned up on my lathe. I have several lathes, but a lot of people don't have a lathe, but almost everybody has a drill press. A drill press is a pretty inexpensive tool, and with a little creative thinking you can turn a drill press into a lathe to do an operation like making this little wooden wheel. I don't know what I'd do if I didn't have a lathe. To me, it's so essential to have a lathe. So it's starting to look pretty sweet. So we compare it to the other one. We might even have to sharpen it up a little more right on the very end. It just tapers into a real sharp little radius there. So we're right on the money as far as positioning. Come up a little more. If you go too much, you reverse it. Not enough, add some more. It's all a little bit, check, check, check. Well, still gonna go more, so. Make sure the gauge goes there. That's the witness mark. So, a little more angle. Alright, so now that angle is fitting pretty nice now, but we're a little wide, so I've got to move the angle inboard a little bit. So now I just make the roller go inboard just a little bit on both sides and it should pull me in nice. Some of that's going to be taken care of by the sharpening that needs to happen. Do this side a little bit more too here. And that should be close enough because we're going to have to sharpen this a little bit. Yeah, see, it's almost there now. So that looks pretty good. Now let's see if we can get these radiuses proper. So you can see now the part is starting to look a little bit like it wants to. It's going to join in on that other piece pretty nice. Once we define this flange here, then it's going to really start to pop. So pick up the gauges. I have to change out my fulcrum block again. I had the real sharp one in. Actually, I probably could utilize that to sharpen that edge up with the slapper. Alright, so I have my metal slapper, and if you haven't seen my video, it's in my library of how to make a slapper using a acetylene torch and some grinders. This was made from a common office chair. There's a nice piece of spring steel in a lot of the common office chairs, and then I had a nice piece of walnut hanging around, and made a really nice slapper out of it. Why a slapper as opposed to a hammer? Because the slapper has a lot more surface area. The hammer, the blow is much smaller, and it'll tend to make hammer marks. And now when you use the slapper, you don't use it this way, you use it the long way generally. I got to get on the other side here. I wanted to move this radius in, so I'm favoring hitting this side. And you can see there's a little curve in this radius. That's exactly what I wanted. Now that's what the original has. And then we check it with our gauge number 43. The witness mark. I was using the gauge over on the edge before. I'm supposed to be inboard a little bit, so looks like I got to go a little bit more. So it needs a little more angle too, so I'm going to push it down. It will want to bend here now. Push that down that way. Push that down that way. And now, see what we have. Look at that. We're on our witness mark and we're pretty close. Now we got to pull this up this way. But before I do that, I want to bring these down because these have, it's always easy to bend the ends of a panel. It's harder to bend the center. So now we got to address that center. Change out the fulcrum block. We're getting long on this video. We might have to make 8C. Sorry about that, but that's the way it goes. Let's do a little bit more and then we'll determine whether, because an 8C, I could finalize all the details on this and weld it to the other piece. So I think that's what we might do, but I'll do a little bit more here. You see, you're getting the content here and the gist of it. I put my gloves on. See if I can get that middle to work a little closer here. It helps when you grunt a little too. So I think I'll revert to using the leather face slapper. I'm running out of oomph and grunting. This is pretty stiff aluminum. It's not annealed. If you annealed it, it'd be a lot easier to do this. And this is, I believe, Chinese origin aluminum, which is very difficult to arrange. The area value pops on it really fast, but it's pretty stiff stuff. The 50 thousandths moves very easy. The 60 gets pretty stiff. And it's nice when your panel is done because it's got great dent resistance. It's got a really nice ring to it when it's done. And I actually love this stuff, but you have to fight with it. It's not easy. But it's so much better than steel. I would make everything out of aluminum. That's the only way to go, in my opinion. So 40 and 41, let's see where we're at now. 41, 40, every gauge has a witness mark. Here's the witness mark for 41 is on this side, and look at that. Just a guesstimate, and we're really close. 40, the witness mark is on this side. Okay, we need a little bit more right there. So we'll bash it a little bit with the slapper. And I think we're getting really long in this video, and that's one of my viewership problems. I think is a lot of people just can't invest an hour, and it just seems to take an hour to do all this stuff. So we might have to go to 8C. Yeah. My cameraman Mark is he's fighting a really bad cold right now, and he wants to go home. So there we go. That should have made a little improvement in 40. Now it still needs a little bit more. So maybe we might get a chance to do this week. If not, it'll be part 8C, which we'll finish this off, trim this, and weld it. No, it'll be this end here. We'll weld this to the other piece. We'll put it in position here, and you see that we still need to pop the flanges on it. And of course, we'll have to work that seam after we weld it, just like we did with the weld in the front nose piece. But there's your beautiful center power bulge. It'll pop as soon as we put this flange on there. So I guess that's going to be it for tonight for 8B. Hope you enjoyed it. Hope you enjoyed the part about the 1937 Riley Swift. It's quite a nice car, and Brian is doing a wonderful job on it. It's really a lot of fun having an extended learning student like Brian in the shop. And keep watching the videos, and please subscribe. Give me the likes, the comments, the questions, and we'll see you soon. Thank you. It's Ray Chalene.